Today's lesson is on volume of prisms and cylinders, and we'll also talk about a principle called Cavalari's principle, which is about oblique solids. Just a quick reminder about what volume calculates. Volume is the number of cubic units, that means little cubes like this, that fill up a space. So this is a three-dimensional unit. 1 cubic unit is 1 by 1 by 1. And when we're finding the volume of a figure, we're finding how many of those little cubes fit inside the figure. So in our first example here, we have a 15 cubic centimeters going this way, 12 cubic centimeters going this way, and then they're stacked up 8 rows of them. So 15 by 12 will give me the number of cubes in that bottom row, and then I need to multiply that by 8 to get the total. Remember, these are all centimeters, so when I multiply all of these together, my answer is going to be in cubic centimeters. Centimeters to the third power, we say that as cubic centimeters. And if I multiply those together, I get 1,440 cubic centimeters for the volume of that solid. On the right, I'm looking for the number of cubes that will fit inside a 5 foot by 5 foot by 5 foot cube. So I can think of this as 1, 2, 3, 5 little feet going this way. I've got 5 feet going this way. So that's 25 cubes in that bottom row, and then they're stacked up 5 times. So by another 5. So I have 25 by 5, or 5 times 5 times 5 gives me 125, and my unit also gets multiplied 5 times, so now I have cubic feet. So now that we remember what volume is, we're going to go ahead and review the base and height of a prisms and cylinders. So we're going to highlight the bases in red. Remember, the bases are the congruent parallel faces on a prism. Congruent parallel faces. So it doesn't matter which way the prism is oriented. What matters is that the non-rectangular faces are the bases, and they are always congruent and parallel. That's the same for a cylinder. My cylinder has bases like this. If I drew the cylinder this way, these would still be the bases. The orientation doesn't matter. What matters is the congruent parallel faces, and they are not the rectangular faces. Those are called lateral faces. Also, just a reminder that we name a prism by its base. So this is a trapezoidal prism, this is a triangular prism, and the last one is also a triangular prism. The height of a prism is the distance between the bases. So I'm highlighting that in blue. It is the distance between the bases, no matter which way it is oriented, and it is perpendicular to the bases. So now that we remember where the base and height are for a prism, we are ready to calculate the volume. And the volume is just the area of the base multiplied by the height of the prism. You'll notice in this example that the base actually is a rectangle, and of course that will be true for a rectangular prism. Over here we have a pentagonal prism, and the base is the pentagon, and the height is that distance between the bases. Here again, that is the height. For a cylinder, it's really the same formula, base area times height, but we have a formula for the area of a circle. So we could use base area times height again, or we can remember that the area of a circle is pi r squared, so that the base will always have that calculation. You may also notice that all of the figures on this page are right prisms and cylinders. And in a right cylinder, the edge of the prism is the height of the solid. Whereas in an oblique cylinder or prism, the height is not the edge of the solid. In this example here, we have the height of this cylinder here. Notice that the volume stays the same, the height stays the same, the base area stays the same, but the height is no longer this edge of the prism here. So if this is the edge, or the cylinder, if this is the edge, it is now longer than the height, but it does not change the height or the volume of that prism. So the formula is still the same. You can see in the second example that we are just kind of shifting the top over, kind of sliding it over, but it is not changing the volume, and again, not changing the height. So Cavalari's principle tells us that if two solids have the same height and the same base area at every level, then they have the same volume. And there's just a picture of kind of shifting that over. So now we are ready for some examples. In our first example, we have a triangular prism. I know that it's triangular because the bases are triangles. So I'm going to write my formula. Volume equals base area times height. And now I need to find the base area, meaning the area of my triangle, and I need to find the height of the prism. And in this case, the height of the prism is much easier. The height is just the distance between the bases. So our height is 20 feet. But to find the area of the base, I'm going to need to find the area of that triangle. So I'm going to pop that triangle out of the picture in red. And I'm going to find the area of this triangle. So I have a 14, I have a 25, and then since the bases are congruent, I know that this is also 25. Now to find the area of a triangle, I have to do 1/2. Notice I'm using little b here for base because I'm talking about this base as opposed to the entire triangle. So I have 14 as my base, and I need to find this little height of the triangle. It's really important to pop this out as a separate picture because now we have two different heights in this picture. So we need to make sure that we're keeping track of what's what. So I have a 14 for the base and I need to find the height. But you'll notice that I created a right triangle here. So in this right triangle, I have a hypotenuse of 25. I have a base of, I have a leg of 7. And if you remember your triples from earlier in this year, that means that 7 squared plus 24 squared equals 25 squared. So the height of that triangle is 24. So I have 1/2 times 14 times 24. Oops, let me fix that B. And then we get 168 square feet. So that is the area of my triangular base, 168, and that's square feet. And now I'm ready to fill in my volume formula. I have 168 square feet times 20 feet. Oh, I missed my square feet. Times 20 feet, that's going to give me cubic feet for volume. And 168 times 20 will give me 3,360 cubic feet. In our second example, we have an oblique cylinder, but remember, oblique just means we need to be careful about the height, that the height is not an edge. So I still have a height perpendicular to the bases. My height is 30, and it looks like the radius of my base is 8. So I'm ready to fill in my formula. I can do volume equals big B, base area times height, or I can write that as pi r squared times height. Those are exactly the same. So we said that the radius that's going to tell us our formula here, our area is 8 pi times 8 squared, and that our height is 30. So when I plug that in, I'm going to get an exact area of 8 squared is 64 times 30 is 1,920 pi. Or if I want to approximate that, I can plug the pi into my calculator and get approximately 6,032 cubic centimeters. We have one last example to do together. In this last example, we are given the volume and we need to find the height. So I'm going to again write my formula. Volume equals base area, in this case pi r squared, times height. And I'm going to fill in what I know. I know that in this base here, the radius must be 5 since the diameter is 10. So I'm going to fill in a 5 for my radius. I'm going to keep the pi and the squared. I don't know my height, so that's going to be my unknown, h, but I do know that my volume is 175 pi. And now I'm really just solving an equation. So I have 175 pi equals 5 squared is 25 pi times h, dividing both sides by 25 pi. I get that. Pi divided by pi is pi, and 175 divided by 25 is 7. So the height of my cylinder is 7, and I'm going to go back and check units. I'm not given any units, it just says units. So I'm done. I found the height of 7. So you have some practice to try using these formulas. I'm also going to include a link in this video if you scroll down to the MCAS formula sheet that you are welcome to use as you do these problems. So, just as a reminder, our objective today was to use volume formulas for prisms and cylinders to solve problems. We found volumes using the base area times height formula. We identified bases and found the areas of those bases. And we also found a missing height on that last cylinder by using the formula.